In this video, we are going to be talking about indices. Now, indices is one of the basic topics you come across in mathematics, and to understand or use the laws of indices to solve problems in mathematics, you must first understand these laws. That is why first we are going to talk about the laws of indices, okay? We are first going to talk about the laws of indices. Now, to help us understand these laws, we are going to be making use of various alphabets and examples, okay, including letters and numbers to understand these laws. There are no fixed number of laws, but then in some books or materials, you find multiple number of laws. This is simply because as we move further, two or more laws can be combined to create a new one. Hence, you find more laws in books, okay? But in this video, we're going to talk about basics and we're going to be solving a few problems on indices. Now, the first law that you should know in indices, the first law you should take note of in indices is if we're having a to the power of m times a to the power of n, okay? Watch, we are multiplying two numbers, okay? Or two alphabets rather, a, and they are having powers, n and m. First things first, how do you identify a power and how do you identify a base in indices? Now, if we're having a to the power of m, for example, the small number on top, which we call the superscript in English language, is called the power in mathematics. Now, another name for power is also known as the exponent, okay? So we can either call it the power or we can call it the exponent. Now, how about the larger number? The larger number is called the base, okay? This is called the power or the exponent. Why this one is called the base? So if I'm having a to the power of m, it means a here is the base and m is the exponent or the power. Now come over here, a to the power of m times a to the power of n, we are having a number having a power multiplying another number having the same power. Now anytime this is happening, okay, what we need to do is we are going to check the base, okay? Know what the base is. These two numbers and the base. Now if the base are similar, that is, if the base are the same, we are going to pick one base and then we are going to sum the power. Hence, we are going to have a raised to the power of m plus n. That is the first law of indices I should take note of. A to the power of n of m times a to the power of n. They are multiplying each other. Since they are multiplying each other, check the base. If the numbers are the same, a and a, we are going to pick one. And if it is multiplication, we are going to add the power. Here is an example. If, for example, we have 2 to the power of 3 times 2 to the power of 5, we have to simplify or solve this. Check, they are multiplying each other. Are the base the same? Yes, they are the same. 2 and 2 are the bases of the equation or expression rather given here, okay? Since they are the same, we can pick just one 2 and then we are going to take the sum of the power, giving us 2 to the power of 3 plus 5, which is 2 to the power of 8. Okay, we are going to simplify further. 2 to the power of 3 plus 5 is what now? 8. That is how it is being done. Over here to law 2. Law 2 is similar to law 1. The only thing we are going to do is that we are going to come to this law 1 and replace this multiplication sign with a division sign. Okay, we are going to replace it with a division sign. So I'm going to write a to the power of m divided by a to the power of n. In this case, what then are we going to have? We're also going to check, are the base the same? Yes, they are the same. Since they are the same, we can pick one and then we're going to subtract the powers. Now take note, we are subtracting the second power from the first power. Okay, so it has to be m minus n, not n minus m. The one that comes first on this left hand side will also come first on the right hand side. So we're going to have a raised to power m minus n. Why are we having a subtraction sign? Because of the division. Now this is the law of indices. Check, if the bases are the same, you pick one. If it is division, we are going to what now? Subtract the power. An example is giving us 2 to the power of 3 again divided by 2 to the power of 5. The bases are the same. We are going to pick 1, 2, and then we are going to take the difference in the powers, which is 3 minus 5. Take note, it doesn't matter if 3 is greater than 5. As far as 2 to the power of 3 is coming first, we have to subtract 5 from 3. So do not make the mistake of writing this as 5 minus 3 just because 5 is bigger, okay? That would be totally wrong. Now, the third law we're going to talk about in the law of indices is a to the power of m in brackets all raised to the power of n. Now, look at this law carefully. What you notice is that we're not having two bases in this case. What we're having is a number or a term in a bracket having an external power. Now, whenever we encounter a case like this, such that we're having a term, having a power, and then there is another power outside of the bracket, okay? Power inside the bracket, power outside the bracket. What is going to happen is that this power outside is going to multiply the power inside. Hence, we're now going to have a raised to the power of m times n. Okay, the power outside simply multiplies the power inside. Here is an example: 2 to the power of 3 always to the power of 2. Okay, there is the power outside, there is the power inside. Because of the bracket, the power outside can multiply the power inside, giving us 2 to the power of 3 times 2, which is 2 to the power of 3 times 2 is what now? 6. So that is how problems like this are being solved. Okay, now for the first law we're going to be taking, the first law we're going to be taking is giving us a to the power of m is equal to a to the power of n. Okay, a to the power of m equals a to the power of n. In this case, what we are going to do is, whenever we are having an equation like this without any other term, like a plus on the other side or a minus on the other side, take note. If you are just having two terms on both sides, there is no plus, there is no minus on one side. Okay, here is what is going to happen. We are going to check if the two numbers on both sides, their base, if their bases are the same, we can cancel them out only if they are the same. Okay, so that we are having a here and we're having a here. So it means since a is on both sides, they can cancel out, and then we'll be left with m is equal to n. That is what the law is saying. Here is another example. So let's say we're having 3 to the power of 4 is equal to 3 to the power of x. Now check. There is no plus, there is no minus on the left and right hand side. Okay, we're just having two terms. Okay, now check the bases. The bases are the same. 3 can cancel 3. What are we then left with? 4 equals what is on top? X. So we can now say x is equal to 4. Okay, that is how a problem like this is being tackled. Okay, so that is how I apply law 4. Now, how about law 5? Law 5 will be similar to law 4. The only difference is that in this case, the exponent or power is going to be the same and the base will be different. Okay, so in this case, we are going to have m raised to the power of a is equal to n raised to the power of a. Now check, there is no plus or minus on both sides of the equation, but then we're having different bases. There is no problem with that. Now check the powers. They are having the same power. There is a here and there is a here. So a can cancel out a, and then we are left with what? M is equal to n. Now this law is similar to law 4. If the powers are the same, they can cancel out and we can equate the base. Okay, and for law 4, if the bases are the same, they can cancel out and we can equate the power. Okay, so similarly, I'm going to do a similar example. Let's say we're having 2 to the power of 4 equals x to the power of 4. The powers are the same. 4 can cancel out 4, so we're left with 2 is equal to x, which means x is equal to 2. Okay, now these are the basic laws, and there is more to it. We are going to take law 6. For law 6, if we're having a negative exponent, how do we deal with it? Okay, let's say we're having a to the power of minus m. Okay, if we're having a negative exponent or a negative power, take note, anytime there is a minus in the power of a number, it becomes the reciprocal of that number raised to the positive power. Now, what is the positive power in this case? It is what now? M or plus m. The positive part of minus m is what now? Simply plus m or just m. Okay, so if we're having a raised to the power of minus m, it means, to simplify this, we are going to take the reciprocal of the base and then put the power without the minus, in the sense that a raised to the power minus m becomes 1 over a all raised to the power of what now? M. Because of this minus in the power, it becomes 1 over the base all raised to the power of what? M. Now, sometimes this could be written as 1 over a raised to the power of n. This is simply because 1 raised to the power m is what now? 1. Okay, 1 raised to the power any number, okay, is always 1. And then a raised to the power m is what now? A raised to the power m. Now, how about the seventh law? We are going to take this as the seventh law. Now, for the seventh law, if we are having a over b all raised to the power of m, notice we're having a fraction. Now, in this fraction, we are having one exponent outside of the bracket. How then do we simplify this? To simplify this, we are going to use the exponent outside to open what is inside of the bracket. So this now becomes a raised to the power of m divided by b raised to the power of n. Okay, the power on top or the power outside the bracket affects the number in the numerator, which is a to the power of m, and also affects the number in the denominator, which is b to the power of m. And that is how a problem like this is being tackled. Okay, or that is how when you encounter a situation or a case in indices where you are required to express something like this or simplify, we are going to apply this law 7. Now, I will always say that you can actually write law 7 before law 6 or law 5. It doesn't really matter the pattern, okay? But most times, to make it easy for students to understand, I always choose to write it in this sequence, okay? No examiner is going to ask you list or state the 7th law of indices, okay? There is no sequence to it, okay? All you have to do is understand these laws and know how they are being what now dealt with, okay? Now, let us take law 8. Now, for law 8, it will still be this case, but we are going to be having a negative exponent again. So we are having a over b in brackets all raised to the power of minus m. Now, first things first, we are going to look at this law that has a negative exponent or power. You notice that for this law, when we are having a negative exponent, what we simply did was to take the reciprocal of the number and then throw out the negative sign. Okay, now if you're asked to find the reciprocal of a over b, it simply means 1 divided by a over b. Okay, the reciprocal of a over b is simply 1 divided by a over b. That is what it means. And if you want to simplify this, b can go to the top to give you b over a. Okay, that is what it means. So the reciprocal of a over b is simply what now? B over a. Okay, that is what it means. Now, how about the power? As far as we've taken the reciprocal of this fraction, what is going to happen is that this negative sign disappears. Hence, we are going to be left with b over a all raised to the power of m. We can now simplify this further, just like law 7. Okay, opening the bracket, this becomes b raised to the power of m divided by a raised to the power of m. Okay, now let us take law 9. Now, for law 9, we are going to be having fractional exponent. Okay, that is what we are going to be having. Now, whenever we are having a fractional exponent, how do we solve the initial problem? Okay, here is an example. We are having a to the power of n over n. Notice that initially we will be solving problems of taking laws such that we are having fractions having whole numbers as their exponents. In this case, we are going to have a whole number as the base and a fraction as the exponent. What then are we going to do in this case? Now, whenever you are having a fraction as an exponent, take note that the denominator of the fraction serves as the root of the base, and then the numerator remains the power. Hence, this is what we are going to have. This now becomes the nth root, okay, of a all raised to the power of m. Now, take note, this m can be put inside of the square root or outside. So I can either write this whole expression as this, or I can write it as, okay, nth root of a all raised to the power of m. So what I'm saying is that you can simply have the power inside of the square root or outside of the square root. It doesn't really change anything. Now, here is an example to understand this law 9. Let's say we're having 2 to the power of 3 over 4. Okay, how do we solve for this? This now becomes the 4th root of 2 all raised to the power of 3. Okay, that is how a case like this is being done. The 4th root of 2 all raised to the power of what? 3. Okay, now Let's now take an additional law which we are going to call law 10. Now remember, initially from the beginning of the video I said that most books will find more or less laws like these ones, okay, as majority of the laws actually include law 1, law 2, law 3 down to law 6, and then most times law 9, okay. Any other one you see here is usually a combination of 2 or more of the laws that we are already having on the board, okay. Now for law 10, I'm going to combine any of these, okay. I can choose to combine law 1 and law 2, law 3 and law 4, or any one. So I'm simply giving law 4 or law 10 rather on the board to show you that it is gotten by combining any of these, okay. So what I'm going to do in this case, I'm going to come here and I'm going to combine law 9, and then when we're having a negative exponent, okay, that is what I'm going to do. So I'm going to have a to the power of minus m over n, okay. So to solve this, we are going to apply the knowledge we've gotten from law 9 and also law 6, okay. So I'm going to come here. Remember, whenever we are having a negative exponent, it becomes a reciprocal. So let's take it step by step. So this now becomes 1 over a to the power of m over n, right? Now applying this law, there is a power outside, okay. It affects both the one on top and the one below. 1 raised to any power is what now? 1, okay. So we're going to have 1 over a to the power of m over n, okay. Now we're going to apply this same law here. The denominator of the fraction becomes the root. That now gives us 1 divided by a raised to power the nth root of a raised to the power of n. That is how a problem like that is being solved, okay. Now I'm going to add something extra, okay. We're going to include this at the law 11. You should always take note that whenever a number is raised to the power of 0, that number equals 1. Now that is something you are going to understand on logarithm, so you might as well want to watch our videos on logarithm to understand how a number raised to the power of 0 equals 1, okay. So a to the power of 0 is equal to 1. Now these are the basic law, okay, the basic laws of indices you are going to make use of in solving any problem. Now trust me, if you can understand these level laws, you should be able to solve any problem on indices that is being given to you, whether A or O level, in your WAEC, in your JAM, or in any exams that you plan on writing, okay. If you can understand these level laws and practice questions and example, you should be able to solve problems, okay. Now we are going to be solving a few problems applying all of these laws, okay, or any one or two of these laws, to see how the laws of indices are being dealt with, or how they are being worked with. Now take note that if you are given problems, you're not expected to apply a particular law. The question is not going to tell you the law to apply. You are going to use your initiative from your understanding, okay. It is not done in one day, okay. It is done as a step-by-step procedure or process, okay. By solving multiple exercises and examples, you get to understand how to make use of these laws. Here is what you are going to do. You are going to look at the problem and think of which of these laws do you need, okay. So let's say I'm solving a problem on indices or logarithm or anything, okay, and I decide, or I get to a particular point where I can no longer make use of the procedures that I've been making use of. What I'm going to do is I'm going to come to indices if I can make use of it, okay, to solve that problem. That is how I'm going to have examples to show you how these things are being done. Okay, so here are a few problems on the board. There are 6 questions here on indices, and these are critical JAM problems asked in various years. This one was asked in 2008, 2010, 2010, 1997, 1999 down to 2009. So there are 6 problems here. Of course, you can attempt more, okay, and then if you're having questions, as usual, you're going to put it in the comment section. But I'm going to solve these 6 based on the laws that we've interpreted few minutes ago or few seconds ago on the board, okay. Now the first question says simplify 16 to the power of 1/2 or minus 1/2 times 4 to the power of minus 1 over 2 times 27 to the power of 1 over 3. Now to simplify this, of course, we are going to apply the laws of indices that we've practiced few seconds ago, okay. Now to solve this first question, I'm going to come here and I'll write solution. To solve this first question, the question is 16 raised to power minus 1 over 2 times 4 raised to power minus 1 over 2 times 27 raised to power 1 over 3. Now, we talked about negative powers. Whenever we're having negative powers in indices, what does it become? This minus in this power now makes the whole expression becomes 1 over 16 raised to the power of 1 over 2, right? Times a negative power again. Now, that becomes 1 over 4 raised to the power of 1 over 2. We're having reciprocal simply because of the negative sign. You notice that immediately after taking the reciprocal, the negative sign disappears. Times 27. There is no negative power there, so that remains 27 raised to the power of 1 over 3. Now, the next thing, fractional exponents. What did we say about fractional exponents? We said that whenever a number is having a fraction as its exponent or power, what happens is that the denominator of that fractional exponent becomes the root of the number or the base. Hence, this becomes 1 over, now 16 raised to the power 1 over 2 now becomes the square root of 16. Okay, now what is the number on top? 1. Now, it is important that you take note of this case. Whenever we're having square root, there's no need of writing 2 inside of it. Okay, so I'll just keep the 2 inside of it. But if it was any number greater than 2, it is important that I write it out. So if I was having 3 there, I'll write cube roots or 4th root or 5th root and so on and so forth. And the power remains the same. But since we're having 1, any number to the power of 1 is that same number. So there's no need of writing this one. Okay, so that is out of the problem. Times 1 over, same thing happens here. We're going to have the square root of what? 4 times, same thing happens here. We're going to have the cube root of 27. Okay, the cube root of 27. Now, 1 over, what is the square root of 16? What number do you multiply by itself twice to get 16? That is 4. So I'm going to have 1 over 4 times 1 over, the square root of 4 is 2. We're going to have 2 times the cube root of 27. It means what number do we multiply by itself 3 times to get 27? That is what cube root means. Now, 3 times 3 is 9 times 3. That gives you what now? 27. So that becomes 3. So the cube root of 27 is 3. Now let's simplify. This is the same thing as over 1. 3 times 1 times 1 gives you what now? 3. Over 4 times 2 times 1 gives you what now? 8. So our answer to this question is simply 3 over 8. You notice that we're not told to apply a particular law in the indices. Okay? What we simply record was that we did certain laws, and those certain laws can be applied in solving this problem. Okay? I'm going to take the next problem, which is question 2. Now, for question 2, which was asked in JAM 2010, the question says, evaluate 81 over 16 all raised to the power minus 1 over 4 times 2 to the power of minus 1. Okay, the question says 81 over 16 all raised to the power of minus 1 over 4 times 2 to the power of minus 1. This is the question. Now, what are we going to do here? We are going to what now? Simplify this problem. Okay, now to simplify this problem, we're still going to apply the laws of indices, of which that is why we're having these problems. Okay, the best way to simplify this problem or make it easy is, instead of expanding the brackets, we notice that we are given 81, now we are given 16. Now we can express these numbers, these two numbers, in smaller forms. That is, I think 16 can be written as 2 to the power of 4. Now, why am I doing that? Because if I write this as 2 to the power of 4, there is 1 over 4 outside, of which if I use this to open the bracket, it can multiply that same power, which simplifies this. Okay, you probably not be seeing what I'm seeing, but then as you practice more problems on indices, it becomes clearer and easier for you guys to understand. Now, 81 on the other hand can be written as 3 to the power of 4, because 3 times 3 is 9, times 3 is 27, times 3 again, that gives you 81. So we can write these two numbers as 3 to the power of 4 divided by 2 to the power of 4 all raised to the power of minus 1 over 4 times 2 to the power of what? Minus 1. Now, how then do we simplify this further? We can open the brackets, right? If we choose to open the brackets, or before we open the brackets, remember we did a law in indices that if we're having a minus in a power outside of the brackets, we can turn what is inside of the fraction upside down. Like 2 to the power of 4 goes up, 3 to the power of 4 comes down, and the minus what now disappears. Now, if we do that, so we're going to have 2 to the power of 4 divided by 3 to the power of 4 all raised to the power of 1 over 4. The minus then what now disappears because we've inverted the numerator and the denominator. Times, now 2 to the power of minus 1, remember negative powers. If we're having a whole number and the negative power becomes the reciprocal of that number. So that is 1 over 2 raised to power what now? 1. And 2 raised to power 1 is also 2. So we can choose to remove the 1 from there. Now let's simplify further. If we choose to simplify further, let's expand the bracket. Now remember, when we're having a bracket, the power outside multiplies the power inside. So we're going to apply that law here. This becomes 2 raised to power 4 times 1 over 4, which is from the numerator, and from the denominator 3 raised to power 4. This power is also going to affect it. So we're going to have times 1 over 4 times 1 over 2. Okay, let's simplify this further. Now 4 here is 1, 4 here is 1, so we're left with 2 raised to power 1 divided by 4 here is 1, 4 here is 1. We're left with what now? 3 raised to power 1 times 1 over 2. Can we simplify this further? Yes. 2 to the power of 1 is 2, and 2 cancels 2. What are we left with? We're left with what now? 1 on top, and then the 3 at the bottom. So our answer to these questions becomes 1 over 3. Okay, so to simplify that, we get what now? 1 over 3. The next problem on the board is question 3 from JAM 2010. It says simplify 3 over 4 of 4 over 9 divided by 9 whole number 1 over 2 in brackets divided by 1 whole number 5 over 19. Now it is important that you know the rule of BODMAS in this case first before solving. What is the rule of BODMAS? Bracket has to be solved first, okay, followed by off. Okay, like in this case we're having off. Now bracket has to be solved first simply means we're going to deal with whatever is in this bracket first. Now inside of the bracket we're still having some certain signs that are used in solving. We're having off and we're having division. Which one do we tackle first? Now for BODMAS, okay, this is BODMAS. Okay, we've tackled the brackets first, so we're going to deal with what we're having here. Now off and division, which one comes first? So we're having off before division, so it means we're going to solve these two terms that are having off between them before we go to division. So for this question number 3, okay, for question number 3, we are having 3 over 4 of 4 over 9 divided by 9 whole number 1 over 2 and then divided by 1 whole number 5 over 19. Okay, now 3 over 4 of 4 over 9, how then do we simplify it? Okay, first things first, we are going to simplify what we are having here. Okay, we are going to simplify what we are having here. 3 over 4 of 4 over 9 simply means 3 over 4 times 4 over 9. Okay, so what will be 3 over 4 times 4 over 9? 3 over 4 times 4 over 9. 4 cancels 4. 3 here is 1, 3 here is 3. So I left 1 over 3, which means 3 over 4 of 4 over 9 is 1 over 3 divided by what we're having here. Now 9 whole number 1 over 2. Let's put it in an improper fraction. Okay, so 2 times 9 is what? 18 plus 1, that gives you 19. So we're having 19 over 2 divided by, converting this again, 19 times 1 is what? 19 plus 5, that gives you 24 over 19. Now let's simplify. We're still dealing with the brackets. Remember, we're not going to go outside the brackets except we're done with it. Now inside of the brackets we're having just division. Now when you're solving division, remember the right hand side becomes the reciprocal, okay, to turn it into multiplication. So we're having 1 over 3 times 2 over 19, okay, divided by 24 over 19. Now sometimes, how do you know you're on the right track? You notice that as you're solving furthermore, most times, it's not all the time though, but most times you start seeing like terms or numbers that can be simplified. I'm saying 19 inside there, I'm saying 19 inside there. We know there is no number that can divide 19 except itself and 1. Okay, so since we're having 19 on both sides, we know most times that we're good to go, although it doesn't happen most times. But examiners in the JAM exams or WAEC exam, they tend to give questions like this when they know these things can simplify themselves. Okay, so inside of the brackets, 2 times 1 is 2 divided by 3 times 19. We don't want to multiply it, let's leave it as 3 times 19, simply because I'm seeing 19 outside and I feel it will make it easier to solve that problem. Okay, so we're having division again, that becomes times 19 over 24. Here's what I'm saying, 19 can cancel out 19. Okay, 2 here is 1, 2 into 24 gives you 12. So we're having 1 on top and our answer becomes 1 over 3 times 12, that is simply 36. So our answer to this question, the JAM problem on indices, 2010 is 1/36, and that is how a problem like that is being solved. Okay, now here is the next question on 1997 jam problem on indices. It says find the value of 4 raised to the power of half or raised to the power of 6. How do we solve a problem like this? Okay, we're simply going to do it by applying the laws of indices we've learned. For question 4, we are given 4 to the power of 1/2 or raised to the power of 6. Okay, now we can choose to open the bracket first or simplify what is inside the bracket. Doesn't matter, both mass does not apply here. Okay, or even if you choose to apply both mass, it's still going to work. Now remember, we're having fractional powers, and when we're having fractional powers, the denominator becomes the root of the base. So this now becomes the square root of 4, okay, all raised to the power of 6. Now the square root of 4 is what now? 2. So I'm going to have 2 raised to the power of what now? 6. Okay, most times it is easier to leave your answers like this. Okay, but if you look at the options in your exam, especially in the JAM exam, because this was a JAM problem, you might want to leave it based on the way that the options are being left. If the options are left in terms of 2, like 2 to the power of 6, no problem with that. But if they are left in just whole numbers without powers, you might want to expand it. That is 2 times 2, that is 4 times 2, 8 times 2, 16 times 2, 32 times 2 again 64. That would be 64. So 2 to the power of 6 will give us what now? 64. So I'm just going to write here 2 to the power of 6 or 64. That is how it is being done. Okay, now for question 5, this was also a jam problem. I think we are going to need to wipe out this place to make it easier for us to solve question 5's problem. Now for question 5, the question says a squared, let me write it out, question 5. The question is a squared b to the power of minus 3 times c all raised to the power of 3 over 4 divided by a to the power of minus 1, b to the power of 4, c to the power of 5 equals a to the power of p, b to the power of q, c to the power of r. And we're asked to find p plus 2r. Okay, we're asked to find p plus 2q rather. We're asked to find p plus 2q. Now, how do we solve a problem like this, okay, on indices? It has to do with your technicality, okay? Now, since we're having different variables b, c, a, p, q, r, you know that we're going to solve a problem like this if we're able to equate both sides. Okay, if we're able to simplify and equate both sides to get p plus 2q and see what it's going to give us, okay? Now, let's first of all try and simplify this problem. To the left hand side, the numerator, we're going to open the brackets, okay? That is going to give us a to the power of 2 times 3 over 4, okay, that is what we're having there, times b to the power of minus 3 times 3 over 4 times c to the power of 3 over 4. We've used the powers to open what is in the bracket, divided by, on the bottom we're having a to the power of minus 1, b to the power of 4, c to the power of 5 equals a to the power of p, b to the power of q, and c to the power of r. Okay, now let's simplify. From the numerator we're having a to the power of 3 times 2 times 3 over 4, that is, we can also reduce this. 2 here is 1, 2 here is 2, so that is a to the power of 3 over 2 times b to the power of, we cannot reduce this one, so we're having minus 3 times 3, that is minus 9 over 4 times c raised to the power of 3 over 4 divided by a raised to the power minus 1, b raised to the power 4, c raised to the power 5 equals a to the power of p, b to the power of q, c to the power of r. Now here is something to make this easy, okay? Instead of taking this upward and writing it again, here's what we're going to do. Now, remember I did say that in the laws of indices, a to the power of m divided by a to the power of n is a raised to the power m minus n, right? Now, this same thing as a to the power of m divided by a to the power of n. The law is still going to apply because these two things means division, okay? They both mean division. So this is also a to the power of m minus n, okay? That's what it means. So if I'm having a on top divided by a below, we're still going to apply the same thing. So for this a, we are going to have a to the power of 3 over 2 minus, what is the power here? Minus 1. Now, most students will make mistakes of using just this minus. Okay, take note. The division is already telling you that you're going to subtract the power. And then there is a minus here, so don't forget to include both minus. Okay, times b to the power of minus 9 over 4 minus 4, right? Times c to the power of 3 over 4 minus 5 equals a to the power of p, b to the power of q, c to the power of r. Okay, now let's simplify. This simplifies to, now, when you solve 3 over 2, minus times minus is plus 1. This simply becomes 5 over 1. Okay, so we're going to have 5 over 2 rather. We're going to have a to the power of 5 over 2 times, okay, to simplify that, minus 9 over 4 minus 4 over 1. LCM is 4. We're going to have minus 9 minus 16. Now minus 9 minus 16 is simply minus 25. So we're going to have b to the power of minus 25 over 4, c to the power of, when you do that, you get 3 over 4 minus 5. LCM is 4. 3, 20. That is minus 17 over 4 minus 17 over 4 equals a to the power of p, b to the power of q, c to the power of r. Okay, now from here we're going to equate both sides. Okay, we're having a here, we're having a, b here, b, c here, c. Okay, we're going to equate both sides. That is, for a, we're going to have a to the power of 5 over 2 equals a to the power of p. Now I did give you a law of indices which said that if we're having both numbers equating both sides and there are no other thing there, okay, we can cancel the bases if they are the same and equate the power. So since they are having a on both sides, they can cancel out, and then p is equal to 5 over 2. So p is equal to 5 over 2. Now for b, okay, for b, we're having b to the power of minus 25 over 4 equals b raised to power q. Okay, equals b raised to power q. So b can cancel out, and then q will be equal to minus 25 over 4. Okay, and then for c, we're having c raised to power minus 17 over 4 equals c raised to power r. C cancels c, which means r is equal to minus 17 over 4. Now if you notice, we're asked to find p plus 2q. So it is actually unnecessary for us to start solving for r, since we know we're not going to be needing r in what we are asked to find. Now we are asked to find p plus 2q. P plus 2q. Okay, p from what we calculated is 5 over 2 plus 2 times q from what we calculated is minus 25 over 4 minus 25 over 4. 2 here is 1, 2 here is 2. So we are left with 5 over 2 plus times minus is minus 25 over 2. Now this simplifies to 2. We're having 5 minus 25. That is minus 20 over 2, which is equal to minus 10. So it means p plus 2q, okay, is minus 10. And that is how this JAM 1999 problem is expected to be solved. There might be a shorter cut, and you guys to it after solving multiple problems and practicing exercises. Okay, now having the last question on our list, which is question 6. It's a JAM problem from the 2009 exam, and it says 5 to the power of 2 in brackets x minus 1 times 5 raised to the power x plus 1 is equal to 0.04. Obviously we are asked to find the value of x. Okay, that's question 6. It says 5 to the power of 2 in brackets x minus 1 times 5 to the power of x plus 1 equals 0.00 or 0.04. Okay, now let's simplify this. To simplify this, first we're having a bracket. Let's make it easy. Okay, we're going to open the bracket for this first term. So this becomes 5 to the power of 2 times x is 2x. 2 times minus 1 is minus 2 times 5 to the power of x plus 1 equals, now take note, even if you're not following this my procedure and you try to attempt a problem like this, okay, to do this, what you're going to do is make use of any method using the laws of indices, as far as you're on the right track. You don't have to simplify this first. Most persons want to pick one base first, then add the powers. Most persons want to convert this into a fraction. But at the end, if we're following the laws, we're definitely going to end up in the same answer. So if you choose to do it your own way and don't end up in with my answer here, you probably made an error somewhere and you might want to what now check. Okay, and this is equal to now 0.04 can be written in fraction. Okay, this is same thing as when we move these dots twice, that becomes 4 times 10 to the power of minus 2 in standard form. Okay, now this now becomes, by having the same base multiplication, we can pick one from our first law of indices, that becomes 2x minus 2 plus x plus 1. So we are adding the two powers. Now that becomes 4 times a negative power in indices becomes the reciprocal of the number. So that becomes 1 over, or rather 1 over 10 squared. Okay, now let's simplify this left hand side. We're having 5 to the power of 2x plus x, that is 3x, minus 2 plus 1, that is minus 1, equals 4 divided by 10 squared is 100. And we can further simplify that. Okay, in fraction, we're going to have 5 to the power of 3x minus 1 equals 4 here is 1, 4 into 100, that gives you 25. So we have 1 over 25. Okay, now what are we going to do here to find the value of x to simplify? 25 can be written in terms of 5, right? 25 is the same thing as 5 squared. So we're going to write this as 5 to the power of 3x minus 1 equals 1 over 5 squared. Okay, we can take 5 squared to the top. Remember, if we're having 5 raised to the power minus 2, it is 1 over 5 squared from the laws of indices. I can choose to take this one to the top back to give you what we're having initially. So that is what we're going to get here. This becomes 5 raised to the power 3x minus 1 equals 5 raised to the power minus 2. Now you can now see that the bases are the same and they can both cancel out. Okay, take note, you cannot cancel out from here and then equate it to 1. Okay, because of this guy is a fraction. Okay, you cannot cancel where they are not fractions. So 5 cancel out 5. We're now left with 3x minus 1 equals minus 2. So 3x is equal to 1 minus 2. 3x is equal to minus 1, dividing both sides by 3. And then x is equal to minus 1. X is equal to minus 1 over 3. Okay, so that is how the jam problem asked in 2009, okay, on indices is being solved. Now we have seen that we've solved 6 different problems that jam have asked from 6 various years. Okay, to solve more exercise or to be better in this topic, what you might want to do is solve more problems. Okay, solve as many problems as you can. Okay, always to get these things, okay, and to make it easier for you. Okay, if you have any more questions or probably you have a topic you want us to talk about, put it in the comment section. Don't forget to like the video if you didn't learn something, or rather also share with your friends. Share it to your friends that are writing the JAM exam or EC exams in A and O levels. Share with those friends that need this topic and other topics or videos we've done on our playlist. Okay, we are going to be solving more problems and also doing other topics that will be useful in mathematics in your coming exams, or if you are just learning for fun. Don't forget to smash that like button like I said initially, and also click on the notification bell so that when a new video is being uploaded, you'll be one of the first 2 persons that will get notified about it. YouTube channel name is Mess.Flash. Of course, you can't click on that notification bell without subscribing. Okay, so you might want to smash that subscribe button as well. See you in the next video. Bye.